Hello everyone, welcome to our presentation today. Today we're going to talk about DOS in NDN. In recent years, the amount of devices connected to internet keeps increasing. In fact, over 90% of internet traffic is used to spread from source to destination. This kind of situation limits the development of current internet. However, the Internet Protocol was not engineered for this purpose. It was instead designed for communication between two remote end hosts, which is based on telephony model. Therefore, a large number of researchers are focused on designing new Internet architectures in recent years. So NDN is one of them. Named Data Networking, aka NDN, is one of the future Internet architectures that are based on the idea of adjusting the contents themselves, rather than writing in the packet's IP address of the host where the information can be found. So the papers our group investigated focus on DOS attack on NDN and the potential solution to DOS attacks. So let's take a look at the NDN composition first. So it's mainly composed by two factors. The first one is namespace design, and the second one is NDN router. Let's talk about the first one, namespace design. Because the name of the data is useful when it comes to routing and forwarding at the network layer, the namespace is designed based on hierarchy and human readability. So in this figure, it's a kind of NDN namespace, which is used by the UCLA campus. Under the same root prefix means these data are all produced from UCLA. Building means the source of data publishing and the user for identity management. So the second component of NDN is that the NDN router. Content store, forwarding interspace, and pending inches table compose NDN routers. We use content store, aka CS, to capture and retrieval content. In this way, when the satisfied interest is given, NDN router will return the corresponding file to user. While for forwarding interspace is a table which has the information about name prefixes and is all outgoing interfaces. By using this table, router can design to continue to the inches to keep finding the target. Pending inches table contains unsatisfied inches and its incoming interfaces. PIT can help find the user who sent the inches, as well as locate the DOS attacker. The paper discussed some aspects of NDN system defense on DOS attacks. The first one is bandwidth depletion. This is a common DOS attack. Sending a massive message to the target as much as possibly by attacker, consuming victims' normal bandwidth is the purpose of attackers. But bandwidth depletion usually could be mitigated under NDN, for NDN router has CS, which include content caches. NDN routers will send message back as long as the interest satisfy content before. The second attack is called reflection attacks. This is a common DDoS attacks. Not only adversary, but also a mass of secondary victims send useless message to other victims. Usually, reflection attacks can be limited by NDN because every interest and contents are corresponding. Finally, only if the victim and the adversary are in same physical network, there would be no efficient attack happen. Lastly, the attack is called black holing by prefix hijacking. Black holing by prefix hijacking attack internet router by making a malicious autonomous system and forward other routers' traffic, leading corrupt them. Because we hardly find or fix the router's information is polluted. The reason for NDN can be reduced, their influence by this kind of attack, is each NDN routers keep monitor the condition of every interfaces and its prefix. Besides, as router has content store and namespace to detect whether or not its information has polluted. This paper illustrates three types of interest flooding attacks based on the type of content requested. Among those, only two of them threaten NDN, which is dynamically generated and non-existent interest. When attacker generate dynamical interest, catching of the content in NDN will lose its advantage about anti-DOS attack. Another interest flooding attacks is generate unsatisfiable interest for non-existent content. Under this attack, the router space would be filled to full. In order to defend interest flooding, author gives us two tentative countermeasures. The first one is monitoring NDN routers information, such as number of pending inches per outgoing interface, and the number of inches per incoming interface, and number of pending inches per namespace. According to author's initial investigation, has shown strong evidence that one can indeed utilize the per packet state built into each NDN router to enable effective DDoS mitigation. Secondly, pushback mechanism could help the victim to isolate the attack source and the location of the attacker. So NDN catch poisoning. Author addresses 2 points about NDN router when they are suffer content catch poisoning in practice. The first one is router need too much of computing power which they cannot afford. The second one is trust management. Routers cannot find a balance point between flexibility and security. In order to deal with it, author introduces a mechanism which calls self-certifying, certifying interest content, aka SCIC. It could determine whether a content is the right one or not without influence its flexibility. So this paper will have practical significance in the future. Firstly, as the development of internet, content transportation through nowadays protocol has become more and more expensive. NDN is an efficient protocol to deal with it. People will use NDN in the future. Secondly, DOS attack threaten internet all over the world. Thirdly, although NDN has advantage about anti-DOS attack, there are some new DOS attacks. If we couldn't find tentative countermeasures, people would suffer greatly losses in the future. However, there are several weaknesses about this paper. First of all, no simulation or experiment is given. Secondly, if an attacker who has pushback mechanism use interest flooding attack, a victim who also pushback mechanism, because the mechanism push an attack all the way back to its source, will lead to infinite attack. Overall, we think this paper's ideas are revolutionary. About the area of how to defend DOS attack in NDN has never been researched. It opens a new view of security of NDN. Thank you very much.